So it's an early start for everyone, I guess. Anyway. So yeah, I'm Sam Wilson. I'm a security systems engineer with Atlassian in Sydney, and here to talk about logging lots of events. Yesterday there was a bunch of talks that produced lots of events, so hopefully there's a few takeaways here that you can use. And ultimately it's TLDR. I'm just going to focus on really the high-level things that we've learned over the last year or so of building a logging platform for Atlassian. So yeah, we went through a process where we eventually moved from lots of disparate teams doing different things to focusing our effort on a single solution. Basically boiled down to a few things. We wanted information, not data, from our logs. We wanted logs really quickly, ideally in real time, but if it's not real time, then close enough, that would be ideal. We wanted a lot of logs, right? This was a solution for the entire company. We wanted to siphon up logs from microservices and big data centers, stuff from everywhere. And ideally, we didn't want to lose any of the logs, because that's pretty important, particularly if these things contain events that you actually care about. So let's take a step back, look at log events. They're usually data. They usually look something like this. And I don't really like these type of logs. They're unstructured. I don't know if these IPs are source or destination. Which of these ports are actually source and destination ports? Are they strings or integers? It's a nightmare. So you figure it out using an ancient, I didn't realize this was like coined in the 60s for databases. Anyway, we still do it for logs. Using regular expressions. And they're not too bad. That one seems pretty reasonable. This one maybe slightly less reasonable. Sometimes you can do validation because these fields maybe contain decent data. Actually, they look more like this though, because the top one is the email RFC and the bottom one is the IPv6 and IPv4 RFCs. It's a nightmare. So I don't really like unstructured logs, if you haven't guessed by now. They require ETL. They're hard to validate because if someone just changes the way that they've started logging and source and destination happen to switch in the last release, your logs are basically useless now. And if you're looking at this thing, you've just restored it out of some cold storage somewhere, and you're looking at this event, there's no context around it. You've just got a bunch of strings that don't really mean much. So I prefer my logs to be information. Ideally like this. I'm pretty biased. It's JSON. But it's great, right? Like you've got clear integer types for source and destination ports. You can see IPs. The entire thing is a key value store. And if you pull this out of Glacier, you still know what the event is trying to tell you. So structured logs, they're parsed by the source. And ideally, if you have a decent logging library, you're not even using regular expressions because it just produces logs in JSON format for you. And the crucial part with JSON is you can validate it. You can write schemas for this, which we've actually done. And we can then say things like, if you're producing log events that don't have timestamps or host fields, we're not even going to accept that into the logging infrastructure. Go back and fix that before you send it to us again. And it creates a decent loop with developers. It's sometimes confusing, but it ultimately means that we have quite rich events. The downside, I mean, it's a downside for some people, I guess, but you do have to log the entire key value structure, right? Like it's JSON, so you have to now carry a bunch of field headers. And if your message is like a one character emit for a stat log event, now you have all this packaging around it. But if you're dumping like stack traces, then JSON doesn't really add much overhead. So big takeaway, I think logging in JSON and structured logging was definitely something that I didn't consider before I started on the logging project, but something that going forwards, I would absolutely start with structured logging first. So that was a bit on logging. Let's talk about infrastructure. That's near and dear to my heart as a systems engineer. And remote syslog is a thing that hopefully all of you are doing. Probably looks something like this. You know, you have different teams with different infrastructure. They're all producing logs somewhere. They're shipping them via some agents, and then eventually they're getting to teams. And they probably have different ways of analyzing logs, like some are using Elasticsearch, some are using Splunk. Eventually, though, some other team comes along, and they set up their Logstash forwarder, and it's great, but the Logstash forwarder is actually misconfigured, and now you're dev-nulling a bunch of logs. But that probably happened to you at some point. Security team's like, hey, I want to know what's going on with these logs, and actually they never arrived. Looking closer at log aggregators, as in these components, you know, you could say that this second tier is basically your log aggregators, right? No one wants to configure 100 different log aggregators. You just call it logs.atlassian.com and you point everything at that. It's great. So yeah, if this was logs.atlassian.com, we have this one Logstash instance where we've got a bunch of sources sending UDP traffic to it, and it probably has to cache it somewhere. So it's got this stateful, you know, either in memory or on disk queue. But if you're in the cloud, you know, it's pretty prone to failure. Like EC2 will just come along and be like, hey, your disk has failed today, sorry about that. And the really insidious scenario here is that, say Elasticsearch is blocking, and then it blocks for a while, Logstash can't forward logs, it starts blocking, Logstash then loses its memory state, or it starts blocking as well, and then eventually you have rsyslog start freaking out because it can't forward sources off the actual sources. It's a bit of a nightmare. So my other beef, obviously, is log aggregators. So I really would encourage moving away from that infrastructure and that sort of architecture. What we've done is to do that, recapping the pain points we found. If you have lots of log aggregators, they're generally in different states, right? Some teams will scale them up. They'll be like, this log aggregator can handle 100,000 events per second. It's great. The team next door are like, it can handle 50 events per second, and then it spikes and falls over. So reliability is hit and miss with aggregators if you've left it with different teams. And scaling them is hard because, you know, if you're dealing with one set of log aggregators, you can generally manage that. But across the board, it's hit and miss at scale. And delivery time is, you know, something that got touched on a couple of talks yesterday. You know, one team might say log aggregators suck. I'm just going to batch everything to S3 once a day. But that's great for a security team who's like, hey, I want events from an hour ago. I'll just wait 25 hours until we batch it to S3, thanks. So yeah, we built logging as a service. This is a project that started to basically collect all the logs at Atlassian, everything from, like I said, our microservices through to the data center applications and everything in between, you know, network engineering kit, any log you can think of. The big difference from what we had previously was that we centralized everything. And I say this honestly, in the platform as a service team where I was initially, we had 7 logging clusters, all running the elk stack, all in various different forms, and it was horrible. So we built one massive cluster instead. Well, we'll get to that. And the big difference was we implemented a data pipeline. I'll also get to that. And the final part was, what we really did was separate our logging infrastructure and platform from applications that produce logs. So this was a team that was focused on just solving the problem of how do we store and analyze logs as quickly as possible. So they built a pipeline based on AWS Kinesis streams and a bunch of microservices consuming these streams. We still use Logstash and FluentD in different aggregators, but the difference here is that teams manage these aggregators themselves, and they submit to a single Kinesis stream in the cloud. What this means is we have a single point of entry into our log platform. Downstream from that is a processing service. This is the thing that's validating JSON schemas for us, throws out logs that are bad, and actually then passes them on to effectively many downstream streams. These streams are effectively multiplexed. So for streams that care about it, we give them everything one-to-one. For streams that don't care, they'll receive a filtered set of events that are perhaps just Zipkin logs or analytics logs or some other type of log. And then finally, there's another set of microservices that will actually apply specific logic to get them into, you know, Elasticsearch or Zipkin or whatever the log format needs to be at the final destination. But crucially, it's not the same logic as the processing service. So we get to decouple everything along the way. So I mentioned data pipelines. There's 2, in my opinion, that, I mean, I'm fairly new to it. There's probably many more. It's something that I hope to share with you guys because it was really not something I knew about until I started on this project. The first one, obviously, is AWS Kinesis streams. I'm biased because this is what we use. We primarily use Kinesis streams because our compute is in EC2, so we may as well do that. But you know, that's what the product spiel says. Sounds pretty good from a logging perspective. If you need to build it yourself, there's Apache Kafka. incredibly similar architecture. Its spiel seems like a pretty ideal scenario for logs as well. And if we look at a stream, shout out to Fabrizio for this article, his blog's here. This diagram is among the best I could find to describe what a stream is actually looking like. There's a lot going on this slide. We have producers on the far right-hand side that are producing log events. They randomly select a partition key each time they want to write this event to the stream. What a partition key is basically just a map of these three shards in the stream. So a shard is a fixed write unit. It either accepts 1,000 events per second or 1 meg of data per second. And it gives you a really easy way of scaling this stream. Like if I have 4 meg a second worth of logs, I need another shard. And it basically means that I can then divide it 25% between each shard. And events flow right to left, unconventionally, but whatever. And on the left-hand side, you can see there's a trim horizon. This trim horizon is crucial in the way the stream behaves because producers' events that come in actually exist in this stream forever until they hit the trim horizon. If the trim horizon is set to 7 days, they'll exist in the stream for 7 days. What it means is that for consumers, they can independently choose their position in the stream. Obviously, they start at the trim horizon 7 days ago, and they read their way left to right. What that means is for a consumer who's behind and processing slowly, they'll eventually get through this backlog. But for consumers that are processing incredibly quickly, they're basically sitting right at the front end, behind the producers, and consuming events in real time. So it means that you can accept a delay without losing data. Effectively the impact of something slowing down or going offline for a minute or two is now you're just behind. You haven't actually lost anything. It sits in the stream until you have a chance to catch up on it. So yeah, that's a high level for the Kinesis architecture. Looking closely at what we did, this is incredibly simplified. It didn't take us a year to build this, but whatever. We have events being created all across the Atlassian infrastructure. Everything produces events, sends it to the LAS pipeline, and then, as I said, we multiplex those out to different places. One of those is cold storage, like basically it just hits S3, we park all the JSON there. And then the other scenario is we just copy the logs into Elasticsearch, give them to developers to look at via Kibana. That's great. There is a service here called the tailing service. For a particular developer, he doesn't want to see 100,000 events from the entire infrastructure. He just wants to see the 20 events from his microservice. The tailing service is also consuming from the stream in the same way. It's just another consumer, but it's only reading the events that it cares about. Crucially, the events that are being created, they only happened once. We didn't actually replicate them, copy them anywhere. They just sit in the stream and we have multiple subscribers. So it's very much pub-sub. It also means that we can choose the right tooling for the right job. So if we want to just go ahead and replace a component, we can do that. We didn't actually change much at all. And it sounds like a big deal to just rip out Elasticsearch, replace it with Splunk. We didn't actually impact any of the log sources across the company. This was crucial because it took us like 12 months to get a few thousand agents configured across the infrastructure. So then once that was done, you can just drop in, get rid of Elasticsearch, put in Splunk. That wasn't really a big deal because everything was always sending its logs to Kinesis stream, like a single Kinesis stream. And Kinesis can scale, so we don't have to care too much, but that decoupling meant that that was actually quite easy. So the takeaways, as far as that architecture goes, I would basically call it out as Kinesis means that our data loss because of incidents or maintenance or anything that really has a chance to impact your logging processing, Kinesis was a massive help there. And it's elastic, right? Like when we started out, this stream was much smaller, but it's the same stream that it was 12 months ago that it is today. It's just much bigger. There's many more shards. A shard now is dealing with maybe 2% load. Previously, it was dealing with 20% of the load. And there's many consumers for the stream. So if you need to just drop something out or replace a tool or build a custom tool specifically for a thing, you can do that without impacting any of the things that are actually producing logs. So I'll talk quickly about Splunk. I'm sorry if I'm getting through this pretty quickly, but we're behind on time. So yeah, Splunk. There was a bit of talk of it yesterday. You would say, how does it fit into this architecture? Basically like this. We have a downstream stream in this case. This is, everything has been replicated into the Splunk stream. It has its own microservice that's processing logs. And we, in the early days, in the first spike, we had the HTTP event collector, which is a relatively new component for Splunk. It's basically a HTTP endpoint that accepts JSON, just raw JSON. So what this Splunk ingestion service does is takes a batch out of Kinesis, shovels it across that way, and we had a forwarding tier here which was pretty disastrous because Splunk TCP load balancing, I'm not sure if you guys have used it, it's atrocious. We had like 20 indexes here, and the forwarding tier, which is getting nicely load balanced data, would then pick one out of 20 indexes and just smash that one. So we eventually decided a better option was to get rid of the forwarding tier entirely, run the HTTP event collector on each of the indexes, just park an ELB in front of it. And what that meant is that we're no longer using round robin for load balancing, but we're using HTTP least connections. And now our individual stream rate per indexer is like 5 meg. So you have 20 indexes that are quite nicely loaded, and they all continue to run the HTTP event collector. The overhead on the HTTP event collector, though, is basically nothing. Like compared to your parsing queues that you deal with in TCP, it was great times. So if you need to scale more, it's pretty easy. Just spin up more clusters, more AZs, and your ELB architecture, everything basically remains the same. So we got pretty fast with this. In testing, because the stream contains 24 hours worth of data, we have to read 24 hours when we first boot up, which was a really good chance to sort of stretch the system. We, in aggregate, exceeded 250,000 events per second. The baseline that we were targeting was a lot lower than that, so we have a pretty healthy ceiling there. And, you know, kind of anecdote, but an individual indexer instance was able to achieve something like 80,000 events per second. We were never getting close to that if we're using TCP, but using the HTTP event collector gave us some pretty good legs. We store a lot. It's kind of easier written like this. It's the name of the talk, so whatever. But yeah, basically, the work that we've done to get to this point in implementing the logging streams and the different microservices that parse logs, it meant getting to this number was pretty hard work, but getting to the next trillion events is pretty easy. Like it's just a unit of scale thing now. We're in a position where if we need to replace components or change it, that's not a scary thing anymore. It's something that a single team within the company can actually deal with. Meanwhile, the rest of the company is able to just continue to produce logs in the exact same way. And you know, if you spin up a new tool, that doesn't particularly change anything. So I think we've come a good way with logging. You know, we went from a solution that was basically tied up in the security intelligence team to now exporting that to the entire company. So we now have teams that are everywhere from growth and product teams, security teams, business teams. Everyone is taking advantage of this real-time streaming pipeline for log events. And ultimately, the risk of losing data now is entirely mitigated because Kinesis streams can cache a week of data. So from an incident maturity perspective, we're in a pretty good place. As far as the summary goes, yeah, these are the real takeaways for me. Use JSON if you have a chance to. Kill off syslog because no one likes writing regular expressions for it. The big win there is that you can enforce clean set of fields. Definitely, if you can use a pipeline, it forms a good abstraction layer between your consumers of events and producers so that you can have a chance to drop things in and out. And yeah, a data pipeline will give you a pretty nice way of dealing with data loss, well, addressing data loss by not having to do it. This architecture that I've described briefly has scaled pretty well for us. It's taken a long time to get here, but yeah, I think being able to hit 1 trillion events in storage and 400T, like that's mainly AWS's work, but that's a pretty good set of growth for us. The HTTP event collector, if you're worried about using it in Splunk, take it from me, it works. It's pretty awesome. The HTTP event collector team at Splunk are actually doing really good work there. And yeah, if you need to look at a log pipeline, definitely check out Kinesis or Kafka. Here's some homework to take away. There's a talk from San Francisco Elasticon last year. Sam Day did a lot of the work on the Elasticsearch side. And yeah, it's well worth looking into that. Failing that, Yelp and Apache Kafka is, well, so Yelp do a lot with Apache Kafka. So Enrico did a talk in Berlin on that. Check it out. I'm out of time, but if there's any questions. Cool, 5 minutes for questions. Hit me. Yes, sir.
So for structuring the data in JSON replacement system, what are we using on those to do that? Splunk forwarders? Or?
Yeah, so the difference in this architecture is we're not using Splunk forwarders at all. Instead, we use Fluentd or Logstash, depending on what the teams want to do. Or if the application is doing it natively, they can do that too, as long as it supports getting it into Kinesis somehow. So yeah, there's definitely plugins for Logstash and Fluentd. But if you have something else, then that would work too. Yes, sir?
Have you considered any commercial open source when you were building it? Or after going through this exercise, would you do it again or consider some open source alternatives like very low patterns?
Yeah, I mean, as you've seen, we've gone through a evolutionary process with it. The Kinesis and data pipeline part really meant that we can make a change later on if we need to. Like we went from an Elk cluster that wasn't really scaling to a Splunk cluster, but 3 years from now, if we need to go to a Graylog cluster, we can still do that. All the front ends will stay the same, which is, you know, when that's tens of thousands of endpoints, that's a huge win. Anyone else? Cool. Thanks very much for having me. Sorry about the accent. It's Australia Day, but I'm sure you can put up with it.